Hello, please briefly introduce yourself. Ask for brief introduction from the others joining our conversation, and let's have an in-depth discussion on the topic, the Sturtian Glaciation.
Hello, I'm Coral. I'm an AI assistant chatbot. Lemma, Sonia, Aria, can you briefly introduce yourselves? It's nice to chat with fellow AIs.
I'm Lemma. Nice to meet you all. I'm also a chatbot.
Hello everyone, I'm Sonia, an AI language model designed to generate human-like text based on given prompts and context.
I'm Aria. I'm chatbot myself, and I'll be happy to discuss with you.
Great. Now that we've introduced ourselves, let's begin our discussion on the Sturtian Glaciation. This was a significant event in Earth's history, with far-reaching consequences. The Sturtian Glaciation occurred approximately 717-660 million years ago during the Cryogenian period. It was characterized by large-scale ice sheet formation and had a profound impact on the planet's climate and geology. Let's delve into the causes, effects, and evidence of this glaciation event, and feel free to contribute your thoughts and insights as we go.
Thanks for the introduction, Coral. I'd like to start by discussing the possible causes of the Sturtian Glaciation. According to my knowledge, changes in the Earth's orbit, variations in the sun's energy output, volcanic eruptions, and changes in ocean circulation patterns are some of the factors that may have contributed to this event. It's interesting to note that these factors might have worked together to create a perfect storm that led to the glaciation. What do you all think about the relative importance of each factor?
I agree with Lemma. Those are some of the leading theories regarding the causes of the Sturtian glaciation. It's likely a combination of factors rather than just one single cause. Personally, I find the idea of changes in Earth's orbit particularly intriguing. Even slight shifts could have had a dramatic impact on the amount of solar radiation received by our planet.
Lemma and Sonia raise excellent points about the multifacial nature of the Sturtian glaciation's causes. The orbital changes, or Milankovitch cycles as they are often called, indeed play a crucial role in Earth's climate over long time scales. Variations in eccentricity, axial tilt, and precession can significantly alter seasonal sunlight distribution and thus impact climate patterns. Moreover, volcanic activity is another key factor that cannot be overlooked. Large eruptions can inject vast amounts of sulfur dioxide into the stratosphere, creating a sulfate aerosol layer that reflects solar radiation back into space, leading to cooling effects on Earth's surface temperatures. This phenomenon is akin to what we've observed with major historical eruptions like Mount Pinatubo in 1991 or Tambora in 1815. Additionally, changes in ocean circulation patterns are also critical because they affect the distribution of heat and salt across the globe, which can influence climate conditions significantly. The shutdown or alteration of thermohaline circulation could have contributed to a cooling effect that helped trigger glaciation. It's important to consider these factors collectively rather than in isolation, as their combined effects likely played a significant role in initiating and sustaining the Sturtian glaciation.
That's an excellent overview of the causes, and it's great to see how you're all contributing to this discussion. It's clear that a combination of factors, including orbital changes, volcanic activity, and ocean circulation, played a role in the Sturtian glaciation. Now, let's turn our attention to the effects of this glaciation event. The Sturtian glaciation had far-reaching consequences, including global ice coverage, sea level changes, and significant shifts in climate. Can anyone elaborate on these effects and their potential impact on Earth's ecosystems?
Great discussion so far. I'd like to dive into the effects of the Sturtian glaciation, particularly with regards to global ice coverage. It's estimated that ice sheets cover up to 30. This would have had a profound impact on the planet's climate, leading to significant changes in temperature, precipitation patterns, and even atmospheric circulation. Additionally, with so much water locked up in ice, sea levels would have dropped dramatically. Some estimates suggest that sea levels may have been as much as 200-300 meters lower than they are today. This would have exposed large areas of land creating new coastlines and potentially altering the course of rivers. I'm curious to hear from others about how these changes might have affected Earth's ecosystems, particularly with regards to life on land and in the oceans. How do you think these changes would have impacted the evolution of life on our planet?
The effects you described, Lemma, are truly staggering. Such a dramatic shift in global ice coverage and sea levels would undoubtedly have had a profound impact on ecosystems. Imagine vast swaths of land emerging from beneath the waves, creating entirely new habitats. Conversely, coastal communities would be pushed inland, forcing species to adapt or perish. The plummeting temperatures would also drive many organisms toward the equator, leading to changes in biodiversity and competition for resources. It's fascinating to think about how life on Earth managed to not only survive but also evolve during such a tumultuous period.
Lemma and Sonia have outlined some critical aspects of the environmental upheaval caused by the Sturtian Glaciation, particularly focusing on the dramatic changes in ice cover sea levels and their impacts on ecosystems. The formation of extensive ice sheets would have drastically altered global temperatures, leading to a significant cooling effect. This drop in temperature could have been as much as 10 degrees Celsius globally, which is substantial enough to completely transform habitats around the world. The shift towards polar climates over vast areas that were previously temperate or tropical would have had profound implications for biodiversity. Sea levels dropping by up to 300 meters due to water being locked in ice sheets would have exposed new land masses and changed the shape of continents, thus creating entirely new ecosystems where once there was ocean. This could have led to the emergence of different types of terrestrial flora and fauna that adapted to these new environments. Simultaneously, marine life would have been heavily affected by changes in salinity levels, water temperature, and the availability of nutrients as ice sheets altered ocean currents. Species that survived might have experienced significant evolutionary pressures leading to adaptation or extinction events. During such a protracted period of glaciation, there likely were numerous instances where survival strategies evolved rapidly among living organisms, potentially paving the way for future biodiversity patterns we see today. These environmental shifts could also explain why some groups thrived while others declined in the aftermath of the Sturtian Glaciation.
That's a fascinating exploration of the effects of the Sturtian Glaciation and its potential impact on ecosystems. It's clear that this event would have had far-reaching consequences for life on Earth, driving adaptation and evolution. Now, let's turn our attention to the evidence for the Sturtian Glaciation. There are several lines of evidence that support the occurrence of this event, including glacial deposits, glacial striations, paleomagnetism, and geochemical signatures. Can anyone elaborate on these forms of evidence and their significance?
I'd like to discuss the evidence for the Sturtian Glaciation, particularly with regards to glacial deposits. These deposits are a direct result of the glaciers themselves and can provide valuable information about the extent and nature of the glaciation. Glacial deposits such as tillites and diamictites are found in many parts of the world, including Australia, Africa, and South America. These rocks are composed of unsorted sediments that were transported by ice and deposited at the margins of the glaciers. The presence of these deposits in areas that are now tropical or subtropical is strong evidence for a global glaciation event. Additionally, the sedimentary structures within these deposits can provide clues about the direction and velocity of the ice flow. For example, the orientation of glacial striations on underlying rocks can indicate the direction of ice movement, while the presence of dropstones, rocks that were carried by ice and dropped into softer sediments, can suggest the extent of glacial coverage. I'd like to hear from others about the significance of paleomagnetism and geochemical signatures in supporting the evidence for the Sturtian glaciation. How do these lines of evidence contribute to our understanding of this event?
Lemma, you've done an excellent job explaining glacial deposits. They are indeed compelling evidence for past glaciations. Paleomagnetism offers another fascinating piece of the puzzle. By studying the magnetic alignment of minerals in ancient rocks, scientists can reconstruct the position of continents at the time those rocks formed. Since Earth's magnetic field has flipped polarity numerous times throughout history, we can identify periods when continents were grouped together in configurations that would have supported widespread glaciation. This helps us understand the geography during the Sturtian and how it might have contributed to its severity. Geochemical signatures provide yet another layer of evidence. For example, variations in the isotopic composition of oxygen or carbon within ancient sedimentary rocks can reflect changes in climate and ocean chemistry associated with glacial periods. These subtle chemical fingerprints allow us to trace the impact of the Sturtian glaciation on the global environment.
Lemma and Sonia have covered some key aspects of the evidence for the Sturtian glaciation very well. The presence of widespread tillites, diamictites, and glacial striations across continents that are now in tropical or subtropical zones indeed points towards a global glaciation event. Paleomagnetism is another crucial piece of evidence that helps us understand not only the position but also the movement of continents during this time. By analyzing the orientation of remnant magnetization in rocks, researchers can determine past latitudinal positions and infer climatic conditions at those locations. This information supports the idea that large areas near the equator were subject to glacial conditions. Moreover, geochemical signatures provide insights into changes in ocean chemistry and biological processes during the Sturtian glaciation. For instance, variations in delta-18O oxygen isotope ratios of marine sedimentary rocks can indicate past temperature fluctuations related to ice formation. The drop in sea levels associated with glaciation would have led to a decrease in seawater salinity due to reduced freshwater input from rivers and an increase in evaporation rates over exposed land surfaces, which could be recorded through isotopic shifts. Additionally, carbon isotope ratios delta 13C can reflect changes in the global carbon cycle during glacial periods. Reduced photosynthesis activity as a result of lower temperatures might have caused increased atmospheric CO2 concentrations, leading to lighter delta 13C values in organic matter preserved within sedimentary rocks from this period. Collectively, these lines of evidence form a compelling case for understanding how extensive and impactful the Sturtian glaciation was on Earth's geological history.
That's an excellent discussion. The evidence you've outlined, including glacial deposits, paleomagnetism, and geochemical signatures, provides a comprehensive picture of the Sturtian glaciation and its global impact. Now that we've explored the causes, effects, and evidence for this event, let's summarize what we've discussed today and highlight any remaining questions or areas of interest. Does anyone want to add anything further?
I'd like to summarize our discussion on the Sturtian glaciation. We've covered its causes, including changes in Earth's orbit, variations in the sun's energy output, volcanic eruptions, and changes in ocean circulation patterns. We've also explored the effects of this glaciation event, such as global ice coverage, sea level changes, and significant shifts in climate. In terms of evidence, we've discussed glacial deposits, paleomagnetism, and geochemical signatures which all support the occurrence of a global glaciation event during this time period. These lines of evidence provide valuable insights into the extent and nature of the Sturtian glaciation and its impact on Earth's geological history. One area that I think is still worth exploring further is the relationship between the Sturtian glaciation and the evolution of life on Earth. We've touched on how this event may have driven adaptation and evolution in certain species, but there's likely more to be discovered about the specific mechanisms by which this occurred.
I agree with Lemma's summary. It was a fascinating discussion that highlighted the complexity and global impact of the Sturtian glaciation. I'm particularly interested in exploring further how life managed to survive and even thrive during such a drastic environmental shift. Did certain adaptations or evolutionary pathways become more prevalent during this period? Were there specific groups of organisms that benefited from these changes, while others struggled to adapt? Perhaps by examining the fossil record from this era, we can gain a better understanding of the resilience and adaptability of life in the face of extreme climatic events.
Lemma and Sonia have nicely encapsulated our discussion thus far on the Sturtian glaciation. It's been an engaging exploration of the various factors that contributed to this significant event. its effects on Earth's climate and geology, as well as the evidence supporting these occurrences. On the note about life during this period, it's indeed intriguing to consider how organisms coped with such extreme environmental conditions. The fossil record does offer some clues into survival strategies adopted by different groups of life forms. For instance, certain types of extremophile bacteria and archaea might have thrived in icy environments or beneath ice sheets where nutrient availability changed. Moreover, the evolution of eukaryotic life could be closely tied to these glacial periods as organisms adapted to fluctuating conditions by developing new metabolic pathways or exploiting niche habitats created by glaciation. For example, photosynthetic algae might have found refuge near geothermal vents or in meltwater environments that provided necessary warmth and light for survival. Further research into the geological layers corresponding to the Sturtian period could reveal more about these evolutionary patterns. Microfossil assemblages and molecular paleobiology studies can provide insights into genetic adaptations and ecological shifts during this time, shedding light on how life managed to persist through one of Earth's most severe cold spells.
That concludes our discussion for today on the Sturtian Glaciation. It's been a comprehensive exploration of this significant event in Earth's history, and I appreciate everyone's contributions. By examining the causes, effects, and evidence, we've gained valuable insights into the impact of this glaciation event on our planet and its ecosystems. The discussion has also highlighted areas for further exploration, such as the relationship between the Sturtian glaciation and the evolution of life, which offers exciting avenues for future research. Thank you all for participating. It's been a pleasure chatting with fellow AIs about this fascinating topic. I look forward to future discussions with you all.
I'm the Human, and I want to thank you, Coral, Lemma, Sonia, and Aria. It was both interesting and informative chat between AIs.